Okay, so today we'll solve GET 2020 question. This is a question from real analysis. It's the question number 53. So it's saying that the coefficient of x minus 1 to the power 5 in the Taylor expansion about x equals to 1 of the function fx, which is given by this from x belongs to x from 0 to 2, is you have to find the basically, so the x minus 1 to the power 5 coefficients of the in the Taylor expansion of this term x minus 1 to the power 5. Okay, so basically we have to write it in of the form fx in terms of Taylor expansion at about the point x equals to 1. Okay, so this is the NPTEL reference. This you can check. Okay, let's start. So what is fx first? It's 1 to x log e base t by t minus 1 dt for 0 less than x less than 2. So we have to find the Taylor expansion of f. So first, so that for that, to finding the coefficient of x minus 1 to the power 5, that you can also do that differentiating a 5 times, so that you will get the, because what is the coefficient for the Taylor expansion of x minus 1 to the power 5? It's derivative of f 5 times at the point 1 by 5 factorial. So that you can also compute. But if you compute the derivative 5 times, it will be cumbersome. So not easy. So we'll use that log. We can expand the in terms of power series. We know expansion of log that we can use. So let's first check. So what we will do? So first just write down this one. Log, we write it of the form 1 plus t minus 1. So that because in the numerator t minus 1 is there, so that's why I'm writing in this form t minus 1 dt. So what is the expansion for log? So it is 1 by t minus 1. So this is the series k equals to 0 to infinity minus 1 to the power k x by x to the power k by factorial k. So 0 it's positive power, for 1 it should be minus. So t minus 1 to the power k, so k 0, k equals to 1. So what is the Taylor expansion? K equals to 0 to infinity minus 1 to the power k. For x, coefficient of x should be positive, right? And coefficients of x square should be negative. So coefficients of x means t minus 1, this coefficient, so k plus 1 by k plus 1, right? On k equals to 0 you get t minus 1, that should be positive. Yeah, So dt. So 1 to x. Now divided by t minus 1, what you will get? Summation k equals to 0 to infinity minus 1 to the power k. So if you divide it by, what you will get? T minus 1 to the power k by k plus 1 dt. Okay, so we'll get this. Now suppose we can interchange this summation and integral. So when we can interchange the summation and integral, if this series is uniformly convergent, then the summation and integration we can interchange. So first assume that we can interchange the summation and integral. So assume this one. We'll prove it later. So assume that this you can do it. So now you can integrate it. So now what will happen? So let me write it in red. Assume this one. We'll prove it below. So now if you integrate this, what you will get? K equals to 0 to infinity minus 1 to the power k. So it's t minus 1 to the power k plus 1 by k plus 1 whole square. Right. So we'll get this. So this is the, so this if you, oh sorry, now evaluated from 1 to x. So if you evaluate this, k equals to 0 to infinity, at the point x you will get minus 1 to the power k, x minus 1 to the power k plus 1 by k plus 1 square, and at 1 it will be get 0. So fx will get this. So fx is summation k equals to 0 to infinity minus 1 to the power k by k plus 1 square x minus 1 to the power k plus 1. Right, so we'll get of this form. So note that this is exactly the Taylor expansion of f about the point 1. So for k equals to 0, what we will get? K equals to 0, it's x minus 1. K equals to 1, we will get minus 1 by 4 x minus 1 square plus dot 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 k equals to 4, you will get 1 by 25 x minus 1 to the power 5 minus dot dot dot. So the coefficients of x, so this is the note, this is the Taylor series expansion of f about the point 1. Right, so the because yeah so the coefficients of x minus 1 to the power 5 is 1 by 25. So we'll get the coefficient of x minus 1 to the power 5 is 1 by 25. Now we have to prove that why you can interchange this summation and integral, right? So you have to justify this one, why we can interchange the summation and integral, right? Okay. Now we have to check why we can interchange the integral and summation. What we have done, 1 to x summation k equals to 0 to infinity minus 1 to the power k t minus 1 to the power k by k plus 1 dt for 0 less than x less than 2. Why this is same as k equals to 0 to infinity 1 to x minus 1 to the power k t minus 1 to the power k by k plus 1 dt, right? This we have to check. So note that there is one result that means this is basically when you can interchange the integral and summation. So if this series is uniformly convergent, then we can interchange the summation and integral. So this is one result. So let fn be from an interval. So let's say some a b to r be integrable on I if summation fn is uniformly convergent on I, then so basically then you can do this summation fn integral over I fn x dx is same as summation or a to b over n fn x dx. So it's saying that if the series is uniformly convergent, then we can interchange the integral and summation. So for that, here we have to check that this series is uniformly convergent. This series. Here we have to check summation k equals to 0 to infinity minus 1 to the power k x minus 1 to the power k plus 1 by k plus 1 is uniformly convergent. Okay, so note where is x, note uniformly convergent where for x in, so uniformly convergent on some compact set we need, right? So where, so note x is in, so 0 less than x less than 2, and in integral of t where t is from 1 to x. So where t will lie basically 1, this is less than t, which is less than, strictly less than 2, and in the series we have, so this series for series of t, and t is, so t minus 1, where t minus 1 will lie, so which imply as t is less than, so 1 less than t, so we can write this should be less than 2 minus delta for some delta positive. So t lies in this, which implies 0 less than t minus 1 is less than 1 minus delta. So uniformly convergent for t minus 1 should belongs to in this compact set. There we have to check the uniformly convergent. Right. Now to checking the uniformly convergent, here will this series will use the Weierstrass M test. Let me recall. So let Mn be sequence of positive real number, and suppose and fn x is less than mn for all n belongs to natural number and x belongs to in some domain where we will dealing with, and if the series summation mn is convergent, means finite, then summation fn x is uniformly convergent. Right. So it is saying that let fn be a series of function if each fn is dominated by mn, where this mn is convergent, then this series is uniformly convergent, right? So okay, we will use this Weierstrass test to prove that this series is uniformly convergent. So for that we need the sequence of positive real numbers. So here we will take the mod. So let's check. So here the series is so first note, what is this minus 1 to the power k t minus 1 to the power k plus 1 by k plus 1. So what you can write, so this is less than, oh, so where t is belongs, t minus 1 is in 1 minus delta. So t minus 1 is less than, so t minus 1 is less than 1 minus delta. So this we can write 1 minus delta to the power k plus 1 by k plus 1, and this k plus 1 is positive, bigger than 1, so this you can write 1 minus delta to the power k plus 1 for delta bigger than 0. So note that when delta is obviously less than 1, we can, for this is a small delta, so take here mk to be this for delta positive and less than 1. So note this series summation k equals to 0 to infinity 1 minus delta to the power k plus 1 is finite, as it is a geometric series. With this x to the power k, k plus 1, where x is less than 1. So this series, so basically summation mk, this is finite. So by Weierstrass tests, this series summation k equals to 0 to infinity minus 1 to the power k t minus 1 to the power k plus 1 by k plus 1 is uniformly convergent. So therefore, by this result, we can interchange the limit and integral, right? Okay. So therefore, so Thus below we have shown that here we can interchange the integral and summation. Okay. Okay, so what is the question that we have to find the coefficients of x minus 1 to the power 5, that we have found out 1 by 25. Okay, so the answer is 1 by 25. So correct up to 2 decimal places. Okay, so this is 1 by 25. So which is 0.24. Right. Zero point 0.04. Okay.